Hello and welcome to this tutorial on Santos Pro. Today we're going to show you an introduction to how Santos predictive models can be used to provide task-focused trade-off analysis utilizing a capability called zone differentiation or zone diff. By recording performance values at each sampled region, we can color code those spaces or zones, making it easy to interpret and differentiate which regions are best to complete a physical task. On your avatar, the first step is to establish an end effector. To do this, we can navigate to a point on the avatar we're interested in this case the tip of the avatar's index finger, and right-click. In the drop-down menu, select Add End Effector. This end effector defines a point on the avatar's anatomy. When trade-off analysis is ran, it will sample performance values according to our end effector and define space. With our avatar and its end effector placed, we can run trade-off analysis and define a zone. In the menu bar above, we're going to go to Windows, then Zone Differentiation. First, we need to select the end effector we created. Next to Zone Effector, select the drop-down menu and select your end effector. Next, we're going to adjust the resolution of our zone. Depending on the use case, you can adjust the resolution as needed. However, for the sake of this tutorial, we will use a resolution of 64 by 64 by 64. To define our zone, select the button labeled Partial Volume. Within the Partial Zone window, we can constrain the zone via three planes: sagittal, the areas to the left and right of our avatar; transverse, the areas above and below; and coronal, the areas in front of and behind the avatar. Next, we will want to select a location for the zone file to be generated. Click on the button with the ellipsis next to Path, navigate to where you want the file to be saved, and give it a name. Now we're ready to run our trade-off analysis. Click on the Go button. To view the progress, click on the Show Batcher button in the Zone Differentiation window. Once the zone has been generated, we can display the zone onto the viewport. Next to Zone Volume Data, select the button with the ellipsis, then select the same button under Manually Specify a File. Navigate to your file and click Open. To display the differentiated zones, check off the X, Y, and Z planes under Edit Planes. Next, adjust the sliders to your area of interest. In this case, our planes intersect in a region near the end effector. By moving the plane sliders, we are able to slice through the data, gaining insight as to how capable completing a task in that region is. The regions are color-coded, from hues of green and blue to yellow and red, which makes it easy to identify where the defined task can be completed. The green regions are relatively the best regions to complete the task. The blue regions are relatively better than the yellow regions, and the yellow regions are relatively better than the red regions. We can fine-tune the contrast of the most optimal regions by adjusting the contrast slider and the color threshold section. We can also adjust how much of that region we want by moving the clip slider. So that concludes this introductory tutorial on trade-off analysis, and we hope you found it helpful. On behalf of SantosHuman Incorporated, thank you for watching and have a great day.